Now, this may seem like a totally different type of study, and it is. And it is. As a pathologist, I always look at disease. In my research work, I always look at many things, management, of course, but many times we have the questions. Is it worth my making that application of that fungicide? If not, when should I do it? These sorts of questions. And so, looking at the literature and wondering about corn versus the way wheat works, I consulted with Dan, I guess it was last year, right after the season, and we looked at, the year before, I guess it was. We looked at the possibility of compensation effect. You know, when you have wheat and you remove certain leaf parts, you tend to get a compensation effect that if you take 10% of the leaf area off, this sort of thing, then you don't lose 10% yield. Okay? Well, what is that in corn? And so we discussed the possibilities and all that sort of thing, and then decided to share in a test in 3 locations at Dean Lee and at Winsboro, was it, Trey? Is that where that's where we tried it? Okay, all right. There were issues there, planting issues there, so that one was lost. And the data I'm going to show you today really are just from my location in Baton Rouge. At some point after we get another year, we're going to start combining our data and we'll look at the entire state. But what I did here is we started looking at defoliation. If I start taking certain leaves off of a plant at various growth stages, what impact is that going to have on yield? Does it have anything? And we found that indeed it does. And it depends upon when that's done and how much is lost at the time. So, that being said, I think we'll move forth. Let's see, no, we'll do this. So the purpose of this was really to predict yield loss in field corn to the defoliators, such as pathogens. It could even be used for insects, whether it's something progressive. We can even look at leaf shredding, frost, hail damage, these sorts of things. So all of that is not just pathology, but we did this because it's a physiological, mechanical thing. It has implications in all the areas of loss. So these are the treatments, and what we decided to do was look at some other studies, use some of their information, decided to change it for what fit us, but we looked at clipping leaves. Now, these first 2 hybrids that I'm going to talk about, they were set up the same way. And here we removed entire leaves at each time, okay? So we looked at the control, of course, we had no detachment, the lower leaves, and we took lower leaves at R1, R2, R3, and at R5. So it's not a cumulative thing. Of course, lower leaves are lower leaves, and so we did it at each of those growth stages. And all the ears below the ear leaf were removed. Okay? So we have ear leaf up is what was left. Then we had some at the R2 stages that we removed at blister, the ear leaf plus the one directly above the ear leaf. At the B and M, that's blister. Then in milk, we removed those same 2 as we saw here, followed by 2 more above those at the milk stage. So in this particular case, we're dealing with 2, and then we took 2 later on. And then if you get here, then we did the same thing, 2, and then as we got to the dent stage, we even took 2 more. Now, dent stage is awfully late, and we understand what's going on physiologically, but while we had the space and the plants, we're going to see if there's any impact. And of course, then we had those at milk, where we took the same ones, the ear leaf and the one directly, and that's all we took in the particular year. Then this one, which is the milk at dent, the same way, and then just taking it dent, which is awfully late in the year, but nevertheless, we wanted to see if any impact. The reason this one in particular goes back to a study that I did with southern corn rust a few years ago. I had a study in which we were able to put a late application of fungicide on corn that had southern corn rust developing almost at dent, maybe 10 days before. And in it, I got a yield difference, and it kind of scared me because I said, you know, this is not something I expected. I figured this was not economical. It may not have been, but biologically, we did some good. Okay? So anyway, that's why we went that late. Now, I'm going to share with you the data here, and I'm going to have to look at it too. Now, first thing is I need to explain this as bushels per acre. Yeah, these are horrible yields. Not an excuse, but an explanation. We agreed upon what? Was it 32 or 34,000 per acre?
Something like that.
Something like that in the lower 30 range. And after the data came to me from my all our harvesting work and all of that, because we had to hand harvest this. You couldn't go out and do this by machine. And so my student workers, my associates, myself, we all got out there and just had a grand time. And after it was all over with, I owed them plenty. But nevertheless, I was appalled at how low the yields were. Nevertheless, I found out in tracking back everything, they had not calculated improperly. What happened is that the tractor driver misunderstood. Communication was an issue, and we probably got only about 24,000. So we got yields that are low. Okay, that being said, forget about the yields. Let's look at trends. This is only 1 year of information anyway.
That's your early hybrid?
Yeah, I believe that's the right one. So here we have control, R1, 2, 3, and 5. All right, nothing happened to these. These just happened to be ones we said are going to be comparison. So if you look at the yield, overall yield there, they're fairly even. So our controls are pretty much in the same boat. But if you start looking at this, you take the lower leaves out at R1. Now, R1 is very early, okay? And so with it, you get a lowering of yield. If you look at R2, where it's a little bit later, yeah, we did get more yield. And R3, we got about the same. And R5, for some reason, it jumped up. Maybe one of those anomalies. Nevertheless, the thing is this one right here, I think, is very interesting because of how early we took those lower leaves. Those lower leaves still are doing something for that plant at that point, okay? We're not later on where we have those deficiencies we're talking about and get the burning at the bottom. We're not dealing with senescence at this point. These are still viable leaves that are doing something for the plant. All right, let's move on. Now we move down the line here. We got the blister at R2, so there is a reduction. But here, remember what we're taking here, not lower leaves, we're taking the flag leaf and the one just above the flag leaf, okay? Flag leaf is that major one that produces a lot of the energy toward yield. So I would expect that. But what's interesting is we go to blister and then we take another one at milk, and it even reduces it more. I would expect that. You just took 4 major leaves out. And then we move on to dent. Even though we added dent into it, it starts at R2, and we go to R5, we still remove some, and we still get a lowering. Versus milk and alone, versus blister alone, you see that it's later in the season. There is more of a yield component that's beginning to form. And then we have the milk and dent. That's still a reduction, but not much of that from the other. And then at dent essentially had no effect. Okay, look at trends. All right, that being said, let's look at the other hybrid that was used. And it's, again, jumps around a bit. These are our controls, and no, they're not quite as even as we had before, but if you look at that, that's probably 90, there may be eight bushels difference there.
Population same?
I'm sorry, yeah, population was the same, yes. Then you look at our, again, at our R1, lowered. We would expect that. These are a little bit higher, but not much. And then R5, of course, we're taking those lower leaves when they are essentially not being used anymore. So there's not much impact. Then we move to blister. We see that we're taking the ear leaf and the one above it, and then 2 above that, and 2 more even above that. And you see the impacts there in the milk. A little bit of a change, but that versus this, not much difference in the other hybrid we did. And then again, starting at R3, the R3 and R5, we're getting a little bit of difference here, but not much. And then dent, of course, there's a little bit of difference, but it's not very much. Now, in thinking about this and thinking about, well, disease comes through, insects come through, they don't always take all of that leaf. We're removing quite a bit of leaf tissue there, okay? Now, it's true that if you get rust is not going to land on the ear leaf or the ear leaf above one and say, that's it, I'm not going to touch any other part of the plant. That's why we did all of these as a sequence. But sometimes we get ear leaves with just a few pustules on them. Maybe it's covered. It's quite a range. And so we look then at just the ear leaf and taking all of it, 3/4 of it, half of it, and 1/4 of it. Okay, something that might be a little more realistic. And that's just what I described here. So let's look at it. And again, we're going to have to look at this one way, and then I've rearranged it for you to look at it a slightly different way. Same data. Our controls are, yeah, they look like forever, but look at our scale here. So that's really 6 to 8 bushels. Look at taking our whole ear leaf at early. It does have an impact. Taking it a little later has a little less. And then these 2 are even later, and it has even less of an effect, and not much at all compared. You take 3/4, you take here a half of that leaf. You see again early on it's reduced, but later on it means less. And then if we get to 1/4, that's not a lot at all. As a matter of fact, if you took the mean of those 4 versus that's probably no difference or even a little better. But I'll rearrange that for you, and let's look at each one in the sequence. Let's look at the controls and all of the treatments in R1 together, and look at the control versus the clipping at the various stages. And if you look at that trend actually makes sense. If you look at it here with the R2, yeah, I'm looking at it differently here. The R2 here, the control is here, and it doesn't seem to make much of a difference in that case. But you look at here, looking at taking out those at the R3, less difference, and as we get later on to the R5, even less. I think the whole point of this is that, and yes, 1 year of data, 1 location, but we're starting to see the impact of these leaves and what they contribute toward yield. We get Dan's data, and if it mimics that, then I think we're on to something. Then after we get another year information this year, because we're going to try it again in all our locations, we're going to be able to see differences. What does this have to do with disease management? Well, what it says to me is when our leaves are attacked by something, whether it's northern cornleaf blight, the rusts, especially southern rust, because it comes in generally in June. If it's a bad year, we get enough moisture, but not deluges because you tend to get spores washed out of the air and actually washed off the tissue. But you get enough to maintain the moisture on the plant and get a lot of what we call leaf wetness, then you tend to get disease development, any of the diseases that we have, but especially the rust. And so when they start attacking, if you will, a plant, then what we've got to do is protect it. Again, we go back to what Harold brought up earlier. When do we pull the trigger? Do we pull the trigger? That sort of thing. And I think that's part of the other studies I've done through the years, and hopefully soon I can put that together for you. I have 12 years of data looking at the epidemics over those 12 years. Some years we get nearly nothing. In other years we get a major epidemic with major losses. In a 5-year period of 2010 through 14, 11, 12, 13, 14, I got a low of 3.5% loss and a high of about 18.9% loss in those years. Those can be significant. 3.5, you're probably not going to worry about. But when it gets to 10, 15, nearly 20%, these are major losses that can occur. These are not statewide, that's not statewide information. These are measurements in my plot, so they're very accurate. But the thing is that we've got to manage the diseases for the entomologists of the world, the insects, anything that's going to attack our leaves, especially our flag leaf and those right around, ear leaf and those right around it, because those are very, very important leaves. So with that, I'll kind of leave you. I know you got questions. I got questions about all this, but the major trends that we see say protect. The next question is, at what point? And I hopefully will be able to tell you that soon too. Yes, sir.
Ultimately, do you think we'll be able to develop thresholds for specific diseases in corn?
That's going to be difficult with any disease on any crop. You know, it's not like the entomologists who say, well, 25 sweeps give you X number of. They're not the Moways of the world, okay? That say you can get so many insects and that should be a threshold. With disease, it's very difficult to say because there's so many factors involved, and not that there aren't factors with the insects, but I think even more so environmentally with our pathogens. So there were going to be differences, and there are going to be differences with hybrids. So it's going to be a nightmare to try to ever do any of that. I think that the article I'm about to put out for Louisiana Agriculture and the 12 years of information that I have with that, I can at least get us a little closer. But whether it's an accurate thing, pull the trigger at this point, no. We're still going to have to use common sense. We're still going to have to be weather people. We're still going to have to look at the other factors involved with the hybrids available and any resistance that's there. The problem with resistance to southern rust is there's hardly any. Okay? And so that is, that's an issue. The RPP9 gene that did give us resistance has been overcome. It was overcome in Georgia back in 2010. It has spread to Alabama. At some point it will be found here. It hasn't been at this point. We have no indications that there is a resistance being overcome here. But there are hardly any hybrids available from any company with the RPP9 gene in it anyway. So that being said, material is susceptible. There are differences in susceptibility, but they're susceptible. Yes, sir.
A little bit different direction.
Uh-huh.
I know it don't pertain to your research here, but I've dealt with some customers in the past that have had issues with short corn, not much leaves. Have you done anything with that just to see?
No, what do you mean short? It just never grew very tall?
You got a plant that's maybe chin high, or 6 feet high, relative to a plant that's 10 or 12 feet high.
No.
Yield, the effective yield between the
No.
leaves and the minor leaf surge.
Yeah, no, I haven't done anything with that.
Some of the years that we've had less growth and less development, we've also, it seems, had less yield. So there seems to be a correlation there, and I was condemned.
Yeah, no, sorry. Do you know any of that sort of thing? Or anybody who's done any of that? It's a start, okay? I wish I had wonderful answers for you, but the reality is that's not where we are. But we're trying to get someplace closer than where we are now.
Just hadn't had time to look at mine.
Well, you know, that's the way it is.
If you get more than 90 bushels,
Oh, yeah, well, we'll get our seeding rate where it should be, then we'll be better off.
Some rough numbers. They're
I agree with you.
around 300, I think.
300.
In his defense, that was in Baton Rouge, it's hard to farm anything.
Yeah. That's right.
Yeah,
The weather they had this year.
yeah, I did. I lost several soybean tests this year, some for him, and just too much water.
It was bad.
It was terrible. Anything else? Well, thank you.